on smart prepaid meter. One of the biggest challenges with utilities is that as a utility, you need flexibility to be able to integrate multiple meters or from different meter suppliers. It's not common now, but we have provided our MDMS solution. Currently, we have integrated over 5 different meter suppliers, open protocol, different network, Sigfox, MBIOT, LoRaWAN. And the network, the way it is, as you see it, we have a densified network. Very interesting. There's a very good relationship between the back-end system, the IoT network, or the network of whatever choice that you're choosing, and the devices themselves. So we, currently the entire city of Botswana, the capital city, we have deployed 18 IoT LoRaWAN network devices. And they're all connecting to all the 33,000 meters. Very interesting encounter. I need to give it out to Leeroy, I think from South Africa, Pretoria. They were our partners in deploying the domestic water meters, SH meters from China. We charge them with the ultrasonic bulk water meters, which are also motorized to allow the utility to do remote open and close of the meters. We also have a super vending platform, very interesting. The project, the way it was in the beginning, was an end-to-end solution for us to bring the devices, the network, the meter data management system, and then the payment platforms. But at implementation, the utility now instructed us to integrate to the existing payment platforms. So we are deploying at the same time, we were doing the changes on the system as an architect so that it can accommodate the structural changes that the utility demanded. Debt recovery, currently our system is also collecting legacy debt. During deployment, what we did, the utility issued a 3-month warning to all the customers to pay their legacy debt. But as you know, people, they always like testing systems, so they just relax and stayed. So what we did a municipal lock on the meter and also on the vending system. So currently the utility, those who have not paid, they lock them remotely from their meter control center, and then they also lock them from able to pay. Even if you have credit on your meter, so they're able to lock you, and then once you have paid, automatically they unlock you immediately, then you've got access to your water. Visual control and enhancement. One of the projects that we did simultaneous to the project, we did a national meter control center for water utilities corporation. Now they're able to control all their meters. They're able to see, visualize the data, and like I'm saying, with the municipal log and stuff, that they're able to see them from that meter control center operation. So we developed the tools that they're using now to do that. Data integrity. It started from the master data that we received from them. So there's a lot of data inputting, data cleansing, data protection, archiving, and that. This is how it looks like currently. So for all of you, I will invite you to our stall outside. We have actually, we're visualizing on our stall. The data is a live environment, and that's how it looks. Those are the 18 gateways, or the 18 network pattern points on a radius of up to 30 kilometers. So we're able to reach up to 30 kilometers of the meters from different areas. Billing and revenue, this is the impact that I'm talking about. What we realized, one, which was the master impact, the revenue jumped from 65% to 98% of the efficiency. And then the financial recovery also, because you are also doing postpaid and prepaid. System reliability, those are the stats. And then the customer feedback, because we also had a customer relationship management system that we deployed at the beginning of the project, so we're able to trigger that. Now the lessons. The master data and social impact, there were a lot of data inconsistencies. There were other customers who were non-billed. There's also now the customer apprehension. The beauty about Botswana is that the customers who actually pushed for prepaid water metering. So, but I know that in other areas, you have to battle now with the clients in terms of change management. The change management structure, the policy and legislation, the biggest problem here was, one, the backbone infrastructure in Botswana could not allow for that rapid change. So that is how we managed to help the utility to set up the IoT network, to have an open source protocol platform, and also at the same time to have devices that are able to meet that realization. I will be sharing more onto the impact and the lessons learned with you, but thank you very much for your attention and listen. Thank you.
Thebe, thanks very much for that. That was really insightful, and I think it follows on from the playbook that there's different ways of approaching this. I've certainly got some questions to ask at the end that I think are interesting to see the challenges in terms of that. Next, I'd like to introduce Angela Nakale, the Acting Manager for Retail for NamWater, who's going to present on transforming NamWater's metering future. Okay.
Thank you. Right, ladies and gentlemen, my presentation. All right. Right, thank you. Good afternoon, ladies and gentlemen. I will be taking you through NamWater's metering transformation, that is from conventional to smart. I am Angela Nakale, as I was introduced, and I am the acting manager for retail, but I am the research engineer with the utility. Right, so in the discussion, I'll give you context as to the case of NamWater, particularly the rural setup within which we operate the retail customers. I'll give you some insight on the current pain points that we're experiencing, why we actually initiated the transition. I'll give you some information on the operations improvement that we have observed, and then go into the opportunities and findings that have come about. And after that, I'll then conclude. All right, so why the change? Some context, NamWater is a bulk water utility inherently. So our customers are large municipalities, mines, schools, and offtakes. Now the offtakes includes the retail customers who falls outside the boundaries of the local authorities. So of late, we have had to onboard local water committee customers who are also retail customers. These were previously serviced by the rural water supply of our Ministry of Water in Namibia. So there is an issue with these retail customers in that there are no individual accounts, whereas they belong to a single account. Therefore, their bills are not individualized, whereas they are clustered. So this brings about issues with payments and consumption. At the moment, NamWater on its own, the retail customers are 54,000. But we expect to onboard over 100,000. So this may put a strain on the current resources, especially our meter reader to water meter ratio. So there will be a strain there. So we do need to move away from manual water metering in order to optimize. Right. At the moment, NamWater's approach is such that we are currently reading manually, so we intend we have transitioned to assisted, and now in the process of initiating or commissioning a pilot for smart water metering. So the challenges that we were having with the manual water meter reading, I'll just give you an example as to, if you can look at the image on the right, we have such a unique setup in our rural area because of we don't have the typical urban town planning. So the water meters are clustered at a central point, and then you have offtakes that leads to now the informal communal housing. So you can imagine the level of human errors if a reader is exhausted and has had a full day in the field. So many of the challenges that we experience result in apparent and real losses because we will experience a high number of metering inaccuracies, handling errors, and of course leakages because there may also be absence of district metering upstream the water meters. So in addition to that, we have poor visibility, and because of poor visibility, there is risk of a high risk of illegal offtakes, meaning that we won't be able to account for much of the water. And this is difficult to detect on time. Only when we do the water balances do we pick up that there are inaccuracies against now what was pumped into the system and what we built for sales. So in addition to that, with the cycle that we read on a monthly, we are not able to identify faulty meters, meaning that a reader can go back 12 times in the year and capture the same reading because we don't do proper analysis, seeing that it's a manual process. We'll only push the bill for the readings that we've obtained. And also that some meters are not read because our rural area is quite vast. We are not always able to get to each metering point. And with that, we also, it's difficult to detect redundant customers. So if you look at a cluster like this, there may be a customer who may have relocated years ago, but the moment we come to this metering point, we sit and still record the reading. So we may be recording a stagnant reading, one for a customer that has moved away, another for a customer whose meter is damaged but still has supply of water. Again, that leads to losses. All right, so what have we done so far? We have, as a utility, implemented assisted reading. So in doing so, we have procured handheld devices, which are fitted with backend system software. This at least enabled us to speed up the reading cycle. And we've observed that we've improved our data acquisition because we now can pick up positions of the water meters. We're able to capture images of the readings. This is now to prevent having to go back to reread to confirm a reading because we can provide the customers with evidence. And again, the readings are more accurate, the quality of data has improved, and we are able to detect anomaly because with these reports, we're able to pull reports for stagnant meters, we're able to pull reports for zero consumption. We're also able to observe the water meter productivity. So with that, we are able to see that our meter readers, they go through the reading process in each cycle faster than what they would previously when they were reading with a paper. All right, and also we are able to immediately transfer readings from the field into the backend system and allow the office personnel to already cleanse the data and be able to submit them for billing. With this implementation, we have encountered, given that the setup of our rural is such that there may be network gaps. So being a GSM-enabled activity, we mitigated this by downloading the routes already in an area where there is coverage. And then with the offline reading capability, we're able to go into the field, provided now we've scheduled the routes in an order that the reader will be taking. Then they're able to go out and take readings while in offline mode. Another is initially seeing that it was a new technology. Some users had trouble, but we managed trouble with the scheduling and troubleshooting. But we had the trainer transfer some of the troubleshooting skills because some of the resolutions will come with experience and exposure to the typical issues that you may encounter. So some of the problems when we transitioned now to the assisted reading is that we needed to have identified redundant customers so that they are not part of the data that is now transported from the master data into the handheld device. We needed to cleanse and make it lean. And there were billing inaccuracies, so the initial previous readings were inaccurate, so there were conflicts when the reader now went onto the ground, that the previous reading did not align to what is actually on the ground. So also we picked up a high rate of vandalism, so many of the water meters were redundant. So these were addressed by initiating other projects for water meter audit, which were not done in the past, in order now to align the data in the master file. Okay. Right, so we have of late initiated the smart water metering pilot. So we have collaborated with a local SOE who specializes in telecommunications. So far we have engaged the customer in order to collect baseline information, to understand the customer behavior. We want we're soliciting buy-in because we are going to operate in the rural area, so we have approached it by contacting the local ground leadership, and we have so far had collaboration or participation from here. The assessments that we have done to date to prepare the system for the smart metering pilot, we have done surveys to know our customers. We have done network readiness assessment because of the vastness of the area, and we have conducted water supply infrastructure readiness. And this also, we are in the process now to conclude the systems and financial reportings requirements before we can then expedite capacity building and then commission the smart water metering pilot. Right. I think the conclusion is that there is a benefit to transition from manual to smart metering. We're looking at improving our data quality as well as delivering our bills on time, as well as being able to identify any issues and anomalies on our infrastructure that can hinder our billing. Okay, I think I'll just leave it there. Thank you.
Thank you, Angela. That was very insightful and an interesting journey that you're going on there. Again, some questions later. Finally, we have a change in speaker. Unfortunately, Kunal couldn't make it today. So we have a suitable replacement, I think, in Ithriam Leukes from Ontec Solutions. So Ithriam, if you can do Kunal's paper for us.
Good afternoon, everybody. My name is Ithriam Leukes. I'm the water business lead for Ontec Systems. If you've seen the profile pic of Cornell earlier, I'm sorry to disappoint you. I don't have the same flaming red hair as she does, but hopefully I can do a justice in delivering a concise assessment of Saldanha Bay Municipality's journey and the deployment of smart metering. I am limited for time. I only have 8 minutes, so I will try and skip through some of the slides and focus on most of the salient points. Saldanha Bay Municipality's journey with regards to smart metering was no different to most municipalities and utilities sitting in the room. Lack of infrastructure, high unemployment rates, spatial and geospatial data not properly confined and conformed. What shaped Saldanha Bay Municipality's thinking, and I think what really moved and accelerated their thinking into smart, was when at a national level, the thought was touted, how about offering fiber as a service? That made them think, and that made them challenge the status quo. In addition to that, I think in the same platform, at national government level, the President indicated that we need to start considering capacitating more young people on digital skills. Challenges, and again, most of these challenges are common with most utilities and municipalities. In spite of, I know that we've spoken a lot over the past day and a half, almost 2 days, of the benefits. We know that smart or AMI metering has the ability to decrease losses, has the ability to improve consistent data, has the ability to improve accurate data. There are some perceptions, and some of them rightly so. One of the challenges that Saldanha Bay faced was, or the perception was, the high cost of deployment. We know that the cost of a manual meter is typically or perceivably more than a smart meter, and we can discuss the perceptions maybe later during the break. The technology challenges, and I'd like to spend a few minutes on these. The technology challenges that Saldanha faced were as follows: multiple meter technologies and the communication types going with those meters, be it NB-IoT, LoRaWAN, or other RF mesh communicating type meters. What device to choose? The security, the cyber security specifically going with that device. And last but not least, in one of the workshops, roundtable conversations we had yesterday, the connectivity types, the connectivity issues, and the connectivity risks. What connectivity best suited for the municipality to embark the AMI journey on? And naturally, a municipality would not want to be locked in with one single service provider. They also wanted to ensure reliability and uptime of connectivity. We know that with most IoT connectivities, there's either drop in communication, drop in connectivity, and then there could be gaps in that consistency of data coming back to the municipality. Baobab, I'll touch on a bit in, I think, 2 slides' time, but why Baobab as the backbone for Saldanha Bay municipality is as follows. Fiber to homes enables real-time consumption for consumers, and we'll read about that a bit later. Accounts leak detection on smart water, and that's fully supported. Big data ingestion. We spoke about the amounts and volume of data that municipalities has to ingest and has to mine with the advent of AMI and smart metering. And it is critical for near real-time and accurate data flow. The traditional means and method in which AMI and AMR or smart meterings are deployed, we've got our meter, and from our meter we have going to our head-end system where data is collected and aggregated, and from our head-end system to our meter data management system where data is then validated and sent down to either a receiving system for a bill to be issued and for utilities to have visibility on what the devices in the field has reported. So that's the conventional system in terms of how smart metering would have been or should be deployed. What Saldanha Bay municipality did, was totally different, and that's why they coined it the Baobab approach. As we know, a baobab has the unconventional shape. When it loses its leaves, it looks like an upside-down tree. And I'd like to read this statement verbatim before I get there. The approach was consumer-centric. They started with an approach in ensuring connectivity to each home, to each consumer, to each household. There was a gradual uptake in signing up. And I want to read as follows. It is not driven by potential clients and uptake. To realize a return on investment, it is driven by providing access to all citizens within the area, and the return on investment is based on building a smart city and creating a more cost-effective and efficient way of engaging our citizens and managing our resources. So they started with the end in mind, started with a sense of consumer centricity. And this slide is probably going to leave some of us aghast. We've heard and we've read that if you roll out smart metering, your losses should decrease. This is not what the slide reflects. The reality is what we found in Saldanha Bay municipality and overlaying historical mechanical data with real-time smart metering data, and I have permission to declare this, Saldanha Bay municipality were overestimating a large population of their consumer accounts. And with overestimating their intake points on consumer accounts, that led to an inaccurate reflection of what their real non-revenue water percentages were. Hence, it is a strategic focus of Saldanha Bay municipalities with their partner service providers to reduce this, and systematically so. Saldanha Bay municipality has just under, I know that the slide here says 6,000, I think it's closer to 7,000 smart meters installed, and we're currently reading between 5,000 and 5,500 of those meters, and the reason there's a gap between what's being installed and what's being read is the GIS information was not effectively captured when the initial contractor started or deployed the smart meters. This is a very busy slide, but essentially what the slide shows us is that what Saldanha Bay Municipality has deployed and what they've commissioned, the same network point that's in the consumer's home is the same network point that they are now using to bring back metering and consumption data. I'm going to skip through the smart POT slide, and we can speak about that maybe during the break. I am at the camp strip table just outside of the auditorium. Why Baobab matters for smart metering? It eliminates unreliable legacy networks, so they've ensured the reliability network uptime, ensures stable, low latency and connectivity for all smart devices, not just water meters. Saldanha has a smart city vision. And this is probably what lies behind the reason to go with a network deployment choice. They want to scale and scale rapidly so. And it is critical for accurate real-time data flow. I'm not going to go through the network issues. I want to focus on the future. What Saldanha's focus on the future is as follows. They want to continue the rollout of smart water meters. In their budget, they have provisioned around 10 million rand per annum for the deployment of additional smart water meters. Very important, the gentleman from MISA spoke about it, and it has been spoken about at length throughout this conference. In order to accelerate AMI and smart metering deployment, there has to be policy change. There has to be bylaw amendments. And Saldanha Bay Municipality is actively looking at how to address that, how to improve that. In addition to that, they also are looking at rolling out CNI meters in parallel with the domestic meter deployment. The CNI strategy is going to focus on the top 10, top 20, top 50 users, and it won't stop there. They also want to listen to beyond the meter. Saldanha Bay Municipality is the first municipality in South Africa that has invested in acoustic leak detection meters provided by Camstrip, and that listens to noise beyond the meters. Most smart meters today listens to, and most leaks that we found and detected is on the consumer side, so that's upstream. Now Saldanha Bay Municipality has invested in technology that can listen to noises downstream, listen to noises on the reticulated side of the meter. Lessons learned. It is evident from the previous speakers that, and there's a lot to learn from different use cases, it is not a one-size-fits-all. Saldanha had to challenge the status quo. They had to believe what was possible. They had to be adaptable, and they had to ensure that they began with the end in mind, ensuring sustainability of connectivity, ensuring that the consumer was engaged right at the start of the journey. Thank you.
Thank you very much to all my speakers there. I think it just shows, as we said in the playbook, there's not one size fits all, and you have a very, very different approach from different utilities there. And I think that really comes across strong, that it has to be suited to the particular utility, the particular challenge, and the particular customer driver there. So that's a really good example of how you've all adopted that and challenged that in a different way. I'm just conscious of time. I've got loads of questions, but I'd like to open it up to the audience first in terms of any questions from the audience to any of the panelists, please. There's one in the middle there, please. Thank you. You can just state your name. That'd be useful.
Hi, Alex Sinski from GLS. To the gentleman for Ontec, if I understand correctly, using the fiber network to retrieve the data from the sensors, what sort of challenges have you experienced with disconnections or any other issues in terms of end users and their internet connectivity, or is it a total separate system?
Alex, I'm going to attempt to answer that question given my insight into the project. So I can respond primarily to the device connectivity. We've actually had very good uptime from a device connectivity and a device reach. So not much challenges in that regard. From a consumer sign-up, the initial sign-up to fiber or internet was, let me not say slow, it was low. But up until 2025, they've had, I think, a near 90% sign-up. So the sign-ups are well ahead of their projected rollout of the smart meter deployment? Thank you.
There's a question on the right. Ken?
Just a question to you, Thebe, the prepaid system in Botswana. Two questions back. Are you not experiencing battery problems with the shut on, shut off, open valve? Because if, you know, poor customers will buy 50 Rand at a time, 50 Rand tomorrow, 50 Rand. When they got money, they'll buy. And the second was around the debt. I didn't quite understand if you're prepaying, why is there a debt issue? I think I probably missed it, but I'm quite understanding why you have a debt issue. If you go and you pay, there's no debt. Thanks.
Okay, no, thank you very much. Let me answer I would not say there are no battery challenges. We do have battery challenges, but they're unrelated to frequency of recharges. So the battery challenges were more frequent because of the network connectivity at start, but it has now stabilized because of how we redefined the architect. And then the meters that we're using, the battery is integrated to the body of the meter, and then it's field replaceable. So the warranty is 10 years. So we do have a second tier support for that through our OEM. Then on the debt, I was only referring to legacy debt. Because when you deploy smart prepaid water metering, obviously you will have customers who are still owing their last, because you have to do your last billing for postpaid, and then you have to give the customer a grace period to pay the legacy debt. So if they don't pay the legacy debt, you then move to the technology so the technology can collect the debt for you. Thank you.
Thank you, and one more question there. I think that's probably time then. So one more question, or two more questions. We'll fit two in quickly, so if you could move the microphone through to the gentleman there.
Okay, thank you. Just three easy questions. To the second speaker, I think that's Angela. I could see that you basically having the manual processes. So I just wanted to maybe understand your process. If the meter reader has identified a new meter on the field, which has maybe not been reported, what's your process? How do you make sure that that meter and the consumption is recognized and up until the billing point? So that is that. And then the same if now the meter has been removed. So your process in addressing that. To the third speaker, you mentioned the issue of networks and all those things. So what I wanted to get is during the time when you're having network issues, what happens to the readings or the consumption from those meters? Do you have them stored somewhere so that you can retrieve them later? Maybe clarity on that. Or let's say the battery is faulty. What happens? Will you be able to get that so much went through during that time? In a perfect world, if the battery of the meter is faulty, we should change it within a day. But in a municipal environment, that can take 3 days to 5 days. So what happens to that consumption during that period? Just the clarity. And it's good that I'm asking a person who's working from the...
If I can just jump in there, sorry, we're running out of time. So do you want to answer that response, if that's okay? Sorry.
Yes.
Yeah, thank you.
Good that I'm asking a person who's working for the municipality rather than getting it from the service provider, because you know that you'll be talking reality. Last one, I don't know if you'd be comfortable sharing this, but how much are you paying to install one smart meter? You mentioned Scamstrang. I don't know if you feel comfortable sharing that, and then add to that your monthly support. I'm sure there is a monthly support that you are paying to the company for faulty meters, access to the dashboard, and all those things, so that you can just get a feel as to how much it's actually costing to have these meters. Thanks.
Okay, thanks. Okay, we're out of time, so you want to give any response to that quickly?
Maybe if I could go very quickly to the speaker's question, to answer your last question, not your last, second last question first. The meter stores historical data for a period of more than 3 years on the register, so those readings will not be lost. And if you recall, I presented that there's a delta between the meters that's installed and the meters that's read remotely. So some of those meters are read manually until they come back onto the system. From an installation point of view, we can speak about the total cost of ownership and installation outside. I don't want to necessarily speak about any commercial aspects on this platform. Thank you.
Yeah, I think maybe to touch on the issue of the, on the issue of the battery, because you did mention about what will happen. I think she will also answer it from the municipal point of view. But as utilities, you must be very, very careful with the type of the devices that you get, because you need to have the meter with the battery embedded within the system, because prepaid is more dependent on the valve. So the same battery that supplies the valve should be the same battery that supplies the meter, such that you have a fail-safe of the battery. If the battery goes down, the fail-safe mechanism with the valve close, so that you have zero revenue loss. Then most importantly also, you must get triggers, because it's not about only the device. The device must be able to give you triggers on the bypasses, pass, tempers, so that you can be able to know if the device is the result. So I think that helps. Thank you.
Right, so I'm going to wrap it up there because I'm being looked over the shoulder. Can I say a big thank you to Ithriam, Angela, and Thebe? I think that was really insightful. Obviously, the guys will be available after to continue these conversations. But thanks very much, and have a good afternoon.
A round of applause for Shaun and his panel, please. Thank you. All right, thank you very much. That was most insightful. And I think, as the gentleman who asked the last set of questions said, having some of the players in the room who actually deal with this on a day-to-day basis was certainly insightful. Before we break up for the various roundtables, I thought I'd invite Amir back on stage just to explain how it's going to work so that you can peg yourself at the right layer for consideration. So Amir, over to you.
All right, guys, hope you're enjoying. Just remember, at the end of today, there's a drinks reception. So, almost there. So, this is exactly like yesterday, except this time, instead of focusing on the finance side, we're focusing on data management. And hopefully, you were listening to my SWAN update, because now we're going to dive into the SWAN circular framework. And how it's going to work is, here's a list of the different layers. And each table is going to dive into one of these layers in depth, in terms of unpacking the challenges, coming up with implementation recommendations, but the same concept where you're very much a participant, not an attendee, so we want to hear from you. So in yellow, those topics will be in the second room over there, and I'll just read those out loud. So we have the physical assets, that's the layer 1, the sensing on the water side, but also on the sewer side. Those will be separate tables. In here, there'll be collection and communication, that's layer 3. Layer 4, 2 tables, one on data management and display, and another one more focused on data integration and data management. And then 2 tables on layer 5, which is on data fusion and analysis, one on digital twins and one on AI. So all the flip charts here have the name of the topic. So if you could move around, and we'll take an hour, and then we'll do the recap session again.
Thank you very much, Amir. I think those are clear. So we'll literally give you 45 seconds to move to your table. Once again, physical assets, as well as the 2 tables on sensing and control, are going